Hello everyone, I am Nitesh. I am super excited in making this video. This small video will talk about how basically software defined vehicle SDV you can realize at home with very minimum cost or maybe nothing. Yeah. So basically without wasting any time I will jump into the concept how basically you can do that. So you might be seeing setup in the screen, but I'll give you a detail. It looks like a very complex, but trust me, it is not. So first, what is SDV? SDV is a software-defined vehicle. It is different from traditional vehicle. And if I give you an example, imagine you have a car. You have some trouble in the car, and you wanted to get it remotely diagnosed. In the current vehicle, which are not SDV, you will find difficult. You have to look into the garage. Yeah, they will, or you are vehicle expert, you can have this OBD tool. You can put into the uh, can connector, and then you see, okay, yes, what fault it is, and you if you are knowing how basically you can diagnose your vehicle. But but in general you have to go to the garage, right? So also, for example, another example is, if you have a new feature you saw in another car, and you want to do same features in your car. It might not be possible because this traditional vehicle is tightly coupled with multiple ECUs, and then bringing out this new application may not work. It required to change in replacement of your ECU or hardware basically. So it is not possible, and that too a lot of complex wirings are there. So that makes it very difficult. So SDV solve these all problems. Not only that, it will give you much more flexibility than this. It will give you flexibility of OTA and SOTA, basically FOTA and SOTA, OTA capabilities, which already I explained you a little bit. Then you have a fleet management. You would have the AI analytics. For example, now there are EV vehicles, and you wanted to see the performance of your battery, and you wanted to basically see some alert if there are some serious issues are there before real problem occurs. So this all can be done taking this data from your field vehicles. For example, you have vehicles which is SDV capable. It will keep on sending data to the cloud. Cloud will process this data, and then it will give you perfect analytics. Things like just a phone. You have a phone today, you want new application, you can download, install it, and then start using it. Same way in future, the vehicle should be designed a way like, okay, you if you have a vehicle, and you just download some of the applications which will fit to your vehicle, and then you just download, install, and start using it. So these are the concept basically STV, software defined vehicle, coming in the future. So it is really exciting, right? So yeah, so basically the same, all these things, either a fleet management or photo update, SOTA update, or AI analytics, and much more. Everything you can do at home with a prototyping, not a full-fledged controller, but you can realize, okay, how basically this all concept works. So I'll give you a glimpse how basically I have set up. So as in the starting of the BD, I said it would be bare minimum cost. But if you are seeing the screen, you might be feeling like there are so many hardwares, there are so many controllers, and there are subscriptions or something. Yes, true. These are there are controllers here. There are the hardwares, but you can skip this part and you can bring your virtualized environment, virtualized system, integrate with this concept, and then you can also proceed. But to have a real feel of the vehicles, real feel of the SDV, what I thought is this two controller will basically act as a vehicle ECUs, and I want to see that. I want to have a feel of, yes, something is happening in SDV. That's the reason I set up this hardware. So I'll explain you also. Yeah, so let's jump into that. I'll give you this all explanation what exactly this does. So if you see that this is a very complex, complex concept, and it cannot be done in one single go. So what I have done is I have segregated in six different parts, and first three part will talk about. One is your hardware setup, second is your vehicle networking, third is basically you will create a telemetry control unit where basically you will send data to the cloud, and from the cloud, what cloud will process this data, and will basically it will store into some Dynamos DB, and basically you further it data can be analyzed, and also from there you can flash something, and you can furthermore explore lot more things. So these are different basically, you know, I have segregated the task. So first part is how basically I have set this hardware. So in this, if you see, we have we have two controller, two ECUs basically, and one is as it is AEB. Okay, one is AEB, it's emergency braking. Second is your basically traffic sign memory. So basically traffic sign memories I have given as a controller, but you can also simulate in single ECU itself. But what I does is, like in one controller I will have the camera will see that okay, if there are traffic sign, it is saying 30 km per hour is the maximum speed allowed in this particular road, or 40 km per hour allowed in this road. This will give the information. After capturing this information, it will send the data to AEB controller, and AEB would have the logic if see that okay, if these are the traffic sign, and if the velocity is high or less, it should be it should be according to the traffic sign maximum allowed basically velocity. It should be basically below that, or if it is more than that, it should give alert, it should give a warning, it should apply a brake or something else. Yeah, so basically yes, so it will do. Yeah, these are two controller, and these are some CAN modules. This is this CAN module is NCP 2515, I guess. Yes, and then we have a Raspberry Pi here. I have used Raspberry Pi 4. So this will act as a TCU. Okay. Yes, and once the hardware is set up, well, we will create a vehicle networking. So what will happen in the vehicle networking is, like as I said, there would be a single CAN bus, and there would be gateway. So this controller is talking on the CAN, and this TCU can also read this in very powerful. It will collect the data from the local issues, and further it will there would be MQTT is a message. What it will do is, this TCU will collect the data from the controller, and through MQTT basically it will send to the cloud. Yeah, so once it will send to the cloud, we'll see how basically things would be processed. So these are the basically hardware sector at the local level. Now let's see what basically it is doing in actual. So here we have one ID. In this ID, you might see that there is a traffic sign. Controller logic has been written, and here we have AEB. So basically now if you see, we are speed limit. It is saying 80 kilometer per hour, and 80 kilometer per hour is the maximum allowed limit in this road, and vehicle is moving right now with the vehicle speed of 30. So it is fine. It is saying it is safe. Now let's suppose I have changed it to 30 speed limit, and I made it vehicle's velocity to 80. So it you see that okay, it say, oh no, it's not in the allowed limit, please apply the braking. So this is basically in the serial communication. You can see that it is working absolutely fine. And now basically if I set the uh, velocity to 40, it is saying okay, it is almost in the range, so you may say it is safe, but this is here the logic is written in this way. But yeah, it should be in the warning. Yes, you have gone more speed is, at least it is not in the same, but this is just a control logic, you can change it later. So you can see once we are changing, there is a CAN communications over here. There is a raw signals basically, how to say, raw signals you can find it in the CAN bus, but these raw signals you can it's really hard to understand what signal is for what. Yes, with the TX and RX ID you can find it, but we have a decoder here. It will tell you what exactly happening. So we have a CAN ID with CAN ID with the TX ID is 0x100, and basically it is saying speed limit is 30 km per hour. And similarly AB state it is saying safe, and then if we change it to 80, it will say braking, and it will change the value to 02, and then it will also say it is breaking. So this is working fine. So this is local communications is established between the controller. Now we have, as I was explaining you, MQTT. So we would have a publisher, we would have subscriber. So basically our TCU, our Raspberry Pi is acting as a TCU which collect the data from these two controller, and then any subscriber, any basically any publisher can basically publish the data, and then any subscriber basically subscribe this information. So this is, we can see that okay, there is a publisher who is publishing a speed limit, AV status, and other basically subscriber is locally finding the information from the local TCU. So what I have done is like, okay, this is local, how basically communication is happening, how TC is acting. I have created one dashboard, a simple dashboard with the flask, which is you might be seeing the left side SDV local dashboard, and it is also explaining you in the real time if you are basically changing any speed limit or ABS status. It is basically explaining you over there in the dashboard. Yeah. So yes, so this is basically on local local network, basically how basically this it is working, and locally how basically you can still publish data and subscribe data in order to have some exchange. Also, if you want to flash something or do something, you can do it locally. But now the major things comes, once this data is basically publishing locally, it can also be published to the cloud, and in the cloud there will be subscriber who can subscribe the data further. So what we have here is, I'll explain you. So yes, so basically we have this IoT, AWS IoT provide you things. Basically, I have created things. In these things, we have basically configured this our TCU. And now what exactly I'll do is I'll have some rule. Basically, I'll activate some rule. It will start sending the data. Okay, and now basically it will have the topic basically selected, and from this topic it will basically see, it will having vehicle has, if anything coming from vehicle has, it will basically having a lambda functions. But before lambda, I want to show you one more thing. I would have them just to see that okay, this MQTT on the cloud side is working fine. I'm just subscribing this same information that I have shown you over there. This is yes, paste. And once I do the subscribe, as I explained you, that it, as TCU is sending data to the cloud, and once this MQTT on the cloud side has subscribed it, it is also fetching the information from the local controller. So basically this is something I was talking from on-road vehicles, the data would be sent to the cloud, and cloud will process the data. I'll show you how basically further data would be processed, but not in basically real use case, that will show you in the upcoming videos. But yeah, so you see here we have how to say, we have uh, the data publishing over here, and if I change it here, if you see, let me, yeah, if I change it over here, just not here, just let me make it bigger. Yeah, so I'll change over here speed limit to 80, and if I see over here, it is saying speed limit to 80, and it will also say EV is safe. Now let's change to 90, and it should change it, it should not say it is safe. So it is, yeah, okay, still saying safe, but it is just because of logic. Let me set the speed limit to 60 and see whether it is safe or not. So it's yes, it's safe. A speed limit is 60 kilometer per hour, and then it started braking. Yeah. So now we see that okay, this is subscribe the data, and the, subscribes basically your MQTT Basically there would be a broker, there would be topic, there would be publisher, there would be subscriber. So this subscribe to MQTT that I want this data to, basically I want to see this data, so it is showing, okay, yes, you can see that, okay, what is vehicle slash whatever the under black vehicle it is coming, you can see over here. So now further what you will do with this data, so it's a huge data. Just you are thinking just two controller is sending this much of information. Imagine if in a vehicle there would be multiple controller, and this multiple controller would have multiple signals sending every millisecond, and it is just one vehicle. Imagine there would be millions vehicles would be running. How basically you control this data? So basically there is a concept. What we can do is I've created one lambda functions, okay, and this lambda functions, basically what it does, it will collect the data and push it to the dynamos dbs, okay. So I can show you, this is the dynamos dbs, and this lambda functions is written over here. So you want lambda functions, this is my lambda functions, and this functions basically is, it says yes, it will fetch the data from the this AWS device, and then it will send it to basically your Dynamos DB. And here is the Dynamos DB. You can explore the table, and you see it is data is reflecting over here. As it will not happen in runtime because I have given the configuration. It can be, but you have to run it. It will basically each time you have to run it, but you can still analyze in the CloudWatch. This is the latest log, and you see here we set the velocity 60, 80, and you can also see the timing and all this stuff. You can find it over here. So what you have seen here is, like, so far is we have basically set the local setup, yeah, and then we have make the vehicle network, and once the vehicle network is ready, we have created TCUs. It is acting as a gateway, and this gateway is basically fetch the information from multiple ECUs, and this ECU, on top of this we have created local MQTT. What it does is, like, in the local, if anyone wanted to publish any data into to this gateway or want to receive anything, they can do that with this MQTT. And once this feature is enabled, mean to say you have the local system ready, then you can integrate cloud, either Azure or AWS. I have shown you in the demo is AWS IoT. You can create a thing, you can configure this device ID, and once it is configured, you can play around with data. You can do this FOTA, SOTA, fleet management, XYZ jet things. I will explain you in the upcoming video, but this is for today that I wanted to explain you how basically you can realize STB at home with the bare minimum cost. As I explained you with the hardware, because just to have a real feel, you can try with the virtual ECUs. In place of this controller, you can have the virtual ECUs. You can have one, co-simulation environment. Once the system is up and running, you can do the same thing what I'm doing in the hardware. So that's all basically for today. If